Okay, so a body of 5 kilograms is placed on a smooth plane that is inclined to the horizontal at an angle of 30 degrees. Calculate I, the reaction force perpendicular to the plane. So here's an inclined plane, 5 kg. The weight is perpendicular. Okay. And this is 5 times 10. Now we have to calculate the reactional force, which is perpendicular to the plane. Now, once this is the mass, the reactional force is always perpendicular to the plane. And on an inclined plane, the reactional force is given by mg cos theta, because this component, which is perpendicular to the plane, is mg cos theta. So when we look at vertical and horizontal equilibrium, we equate R, the reaction, to this, mg cos theta. So this is the reactional force on an inclined plane. Okay. Once the angle of tilt is 30, and the mass is 5 kilograms, then the reaction force becomes 5 by 10, which is 50, times cosine of 30. And this is 550 times root of 3 on 2, which is 25 root of 3. When you multiply 25 by this, I think this is 40, what? Is it 43?
Yes, sir, 43.3013.
Okay, Newton. So this is the reaction force perpendicular to the plane. Then the next question requires that you calculate the resultant force acting down the plane. Since this is a smooth inclined plane, there is always the mg sine theta, which is acting down the plane. And since there is no resistive force, okay, this is the resultant force acting down the plane. So the resultant force acting down the plane is equal to the mg sine theta component. The mg sine theta component. Therefore, this is equal to 50 sine of 30. Sine 30 is half. So this is 25 Newton. All right. Then the acceleration of the body. The acceleration of the body. Once this is the resultant force acting down the plane, okay, whenever there is a resultant force, there will be acceleration. So it means that the resultant, F resultant, is equal to m times A. Therefore, A, which is the acceleration, is given by F resultant divided by the mass. And the resultant force is this. So 25 divided by 5, giving us 5 meters per second squared. This is the solution to the first question. Please, any confusion? If you are not clear with something, let me know so I could explain. If you are okay, then let's move on to question 2. Do we move on? Okay, then I'm adjusting the camera. So where are they? Who else has joined? Mami Araba, Janice, Ishra, Yarad, and Equia. Awesome. Okay. Then the second question. A body of mass m kilogram is placed on a smooth inclined plane of an angle 42 degrees to the horizontal. So we also have an inclined plane. We once again have an inclined plane. The angle of tilt is 42 degrees. We have a mass which is not known, an unknown mass m kilogram. Okay. It's placed on a smooth inclined plane of angle of tilt this. Then the normal reaction perpendicular to the plane is 14.9. So over here, we are told that the normal reaction, if there is the weight, the normal reaction perpendicular to the plane R is 14 points that. Okay, so the reaction is equal to 14.9 Newton. But we understand from an inclined plane that reactional force R is given by mg cos of theta. So if the normal reaction is this, then when we equate 14.9 to mg is 10, cos of the angle of tilt is 42. So with this, we can easily find m. M here would be equal to 1.49 divided by a cos of 42. And that is approximately equal to 2.00 kilograms. All right. Are we fine? Hey, human beings or beings, you are quiet. Are you
Yes,
there?
please.
Everything is okay.
Okay, then I. The force parallel to the plane that is needed to hold the body at rest. Now we have this. You know, on an inclined plane, there is always an existing mg sine theta. Now the question is demanding a force which is parallel to the inclined plane, which will just hold this body at rest. So assuming the force which will hold this at rest is P. Once this is expected to be stationary, then it means P must be equal to the resultant force which acts down the plane. Okay, so for body to be stationary or to be held at rest, then it means P must be equal to mg sine theta. Now, if P is greater than mg sine theta, what happens? If P is greater than mg sine theta, what happens? Mhm.
Sir, please, the body moves upwards.
Or technically, what will you say?
There will be an
The
acceleration.
body
There will be an acceleration. Good. So here we want to keep this body at rest. So we are looking for the force which will keep the body at rest. Now, therefore, P is equal to mg, the mass we found is 2. J is 10. Sine of 42 degrees would give us P. So 20 times sine 42 would be equal to 20 times sine 42. Mami Araba.
13.38.
13.38. Mami Araba, are you there? Okay. Then B. The B question. But Mami Araba, you are here.
Please.
You have a toy looking at your camera. Once you are not saying anything, it's okay. So the B part, if the parcel is pulled up the plane by a force 20 Newton parallel to the plane, find I, the resultant force. Okay, now this time around is the same thing, but this time we are looking at, in this particular situation, the B situation, we are looking at the body being pulled up the plane. And for the body to move up the plane, it means this force P must be greater than the opposing force mg sine theta. Is that okay? So if this parcel is being pulled up the plane by a force of 20 Newton, then it means that the resultant force, I'm coming in. I've missed the question. Okay. It means that if the force is 20, then the resultant force up the plane must be this minus this. It must be 20 Newton minus mg sine theta, which is 13.38. 13.38. What's the result? 20 minus 13.38.
6.62.
6.62 Newton. So if it is pulled by 20 Newton force up the plane, that will be the resultant force. The acceleration with which the body moves. Once it is moving up the plane, its acceleration, the resultant force must be equal to m times a. Therefore, the acceleration is equal to the resultant force, which is 6.62 divided by the mass, which is 2. So 6.32 divided by 2. This is equal to what? 3.1. Every 3 points.
31.
Meter per second squared. So that's the solution. That's the solution. Any question?
Mr. J, please, if you get an answer like 2.8, 2.93. Is it still correct?
For
The acceleration.
2 point what?
8.
But how did you manage to get 2.8?
I use the same procedure.
Ah, the same procedure and you had different results. Is it
Yes, please.
is it the same figures?
I had a mass to be 1.94 kg.
1.94.
Yes, then I used that.
I suspect in determining the mass, instead of reaction being mg sine cos theta, you use sine theta. Maybe you mistakenly equated the reaction to mg sine theta instead of cos theta.
I used cos theta.
So if, let's see, 14.9 j is 10, sine of 42, cos of 42, and how come you got 1 point that? I'm
I
surprised.
divided 14.9 divided by 10 cos 42.
Eh, it's the same thing. M is equal to 14.9 over 10 times the cos of 42. And so you point cos 42, multiply by 10, then divide your results by 14.9. So how come you are not, you never got 2?
Please, now my calculator is giving me 2.00, but initially it gave me 1.94.
Eh, maybe it's your calculator angular measurement in the radian.
It's at D.
And maybe it's you see, when you are inputting this, you have to go step by step. Find cos 42, multiply by 10, whatever you had, then you divide by 14.9. If you jam everything together, the calculator can interpret it differently and can possibly give you different results. Any more question? Hello, any more question? Okay. Then I give you this other question, which looks bulky. A body of mass 10 kilograms. Let me clear the board. Do I clean it?
Yes, sir.
Dennis, are you following?
Yes, please.
Ishra, are you there?
Yes, please.
Ado Asante, are you back? Or she's still eating? Maybe. A body of mass 10 kilogram resting on a smooth surface. This time, it's not an inclined plane. The body rests on a smooth surface. Okay, so the body rests on an inclined, smooth surface and is acted upon by the forces. So let's list the number of forces. We have the mass being acted upon by 18 Newton at 310 B. Another force B, 15 Newton, 90. C, 20 Newton, 215 degree. And D, 25 Newton, 180.
Sir,
So we have
hello,
4.
sir.
Hello.
Sir, please, you have not given me and Gerard this question before.
Really?
Yes, please.
Okay. So we have 4 forces acting on the body. Now we have to calculate correct to three significant figures, the resultant force acting on the body. We have to determine the resultant force acting on the body. So here we have 4 forces acting on the body. And when you have 4 forces acting on a body, you must resolve each one into component. It's like, let's draw something. This is the y-axis. This is the x-axis. The body is here. Okay. These are vectors. Angular measurement is taken from the north. So a force of 18 Newton acting at 310. So this is from the y-axis. We have, meaning 310 will be 270. 270 plus 40 would give us 310. So let's assume this is an angle of 40 degrees from the x. This is 310. So this is 40 degrees from the x-axis. So 40 plus 270 would give us 310. This is 18 Newton. For A. So this is the force A of magnitude that. Then the second force, 15 Newton acting at 90. In bearings, angular measurement is taken from the north. So this is 15 Newton. This is B. Or let me bring it here. Then the force C of magnitude 20 Newton acting at 215. This is 180. 180. So 20 would give us 200 plus 15. So that would be 35. So 35 from 180. So let's assume this is 35 degree, meaning plus this would give us this angle. So this is 210. Sorry, 20 Newton. And this is the force C. Then D, 180. 180 from the north will be here. This is D, or magnitude 25 Newton. D. So this is a representation of all the forces on the XY plane or within the Cartesian plane. Okay. So if I want to resolve each and every one into components, for resolution of forces into components, whenever you are taking into consideration the angle it makes with the y-axis, then the order becomes sine theta again and cos theta for x and y. if you are taking the angle from the x-axis, the angle it makes with it, then it is cos theta as against sine theta for x and y. So I want us to use the angle individually it makes with the y. Okay, so when we pick this first one, A which is 18 Newton, 310 Newton degree into component will be equal to 18 sine 310, then 18 cos 310. This is because I'm considering the angle from the y-axis. So I'm using the angle direct. And what is sine 310? Yes, what is sine 310? That's equivalent to sine 40 but negative. So point for me. Acquire sine 310.
Minus 0.766.
Have you multiplied by 18?
Times 18 will be minus 0.788.
Minus 13.788.
8.
789.
Yes, please.
Then cos 310 times 18.
Sir, please, 11.57.
11.57. So 11.570 because we made a 3dp. Then let's look at for B. B is 15 Newton acting at 90. So this is 15 sine 90, 15 cos 90. So sine 90 is 15, cos 90 is 0. So we have 15 Newton against 0. Then C, 20 acting at an angle of 215. So this is 20 sine 215, 20 cos 215. Yes. 215 is equivalent to 35. So what is 20 times sine 215?
Minus 11.471.
472. Okay, when you are running, open your eyes. Then 20 cos 215. Minus 16.383. Then last one, D. 25 180 degree. So this is 25 sine 180, 25 cos 180 degree. Now what is sine 180? That's 0. Okay, uncle, I'm waiting.
0.
And cos 180 negative 25. So we have resolved each and every one into the vertical and then the horizontal. So let's look at summation f of x, meaning we are going to sum up all the x's in each one. So minus 13.789 plus 15 minus 11.472. Okay. Then summation f of y equals 11.570 minus 16.38 minus 25. So sum the x's and sum the y's up for me. Somebody should pick x, somebody should pick y, and then do it for me.
So yeah, please, the x is minus 10.259.
Minus 10.259. Then the y. Gerard and Kenneth, what were you doing? Ishra and Co, what are you doing? What are you doing? I asked you to take, somebody should take the S, somebody to take the Y. Gerard and Co, what are you doing? Okay, I'll go ahead.
Y is equal to minus 29.813.
29.813.
Yes, please.
So let's represent them. We are looking for the resultants though, but we realize that the X component is a negative, whereas the Y component is also a negative. So it will be here. So this is summation f of x, which is 10.259. Then the summation y is also a negative, which is here. F of y. So we have 29.813. Hello.
Sir, please, I have a problem with the sigma f of x.
What's the problem?
So I had negative 10.261.
You are adding all the x's.
Yes, sir.
So the x is negative 13.789. Then that of B is 15.
Yes, sir.
That of C is negative 11.472. That of D is 0.
Yes, sir.
So you have 15 minus 13 points, that minus 11. Let's confirm. Let's all do it. Let's be involved in what we are doing. So the x is negative 10.261. Negative 10.261. Yes, she gave us, Equia gave us negative 10.259, which is close though. But let's change that to 6.1 Newton. And Gerard, what is the problem?
It's okay. It's a negative 10.261.
So, Mami Araba, take part. Take your calculator and then be part. Insurance speak. Janice, let's contribute, okay? When we all get involved, then we can do things quickly and then. So, the resultant, therefore, let's draw an equal vector to this. So, the resultant will be here. Will be in this direction. Okay, and since this indicates a kind of right angle triangle. We use Pythagoras theorem. Therefore, r squared is equal to summation of f of x squared plus summation of f of y squared. R therefore is equal to the square root of our values. Put them in 10.261 squared plus 29.813 squared. If you use substitute negative, they will be squared, so the value is the same. So let's calculate for the resultant. Mami Araba, you tell us the answer. So get ready. I'll take Mami Araba's answer. Mami Araba, what did you get?
Please, I had 31.53.
So R is 31.53. That's 31.53 Newton. So that's the resultant. That's the resultant. Then the next question requires that we calculate for. Hey, what's the next question? Hello, what's the next question? Calculate for the acceleration with which the body begins to move. The acceleration with which the body begins to move. Inshira, I'll take your answer. So Inshira, we are waiting for you. Calculate it and tell us what you have as your answer. The acceleration with which the body begins to move. Inshira, what did you get? Inshira, are you there? Huh? Janice, tell us what you got. Janice. The acceleration with which the body begins to move. Janice, are you there? Hello, Janice. Oh, okay. Let's do it. Hey, okay, how would you calculate for that? How would you calculate for the acceleration?
You use the formula for force, which is F is equal to ma. Then you make acceleration the subject. Then you substitute
Exactly. You
the
see,
resulting mass.
thank you. From Newton's second law, once there is a resultant force, a body would accelerate. Okay, the body will be stationary if the resultant force is 0. But once there is a resultant force, the body would accelerate. And this value of the acceleration is determined by, so the resultant force is equal to m times a. Once, so A is therefore equal to the value of this resultant force, 31.53 divided by the mass. And what's the mass of the body? What's the mass of the body given to us? 10 kilogram. 10 kilogram. And so we have 3.153 meter per second squared as a acceleration. It's not any difficult question. Then C, the time it takes to cover the first 5 meters. What's the time this body takes to cover the first 5 meters? So I'm giving you 2 minutes. Think through this question and answer it for me. The time it takes to cover the first 5 meters. Let's see. The time it takes to cover the first 5 seconds, 5 meters. The time it takes to cover the first 5 meters. Finished? Class finished?
Yes, please.
Okay. Gerard, Janice, and who have you tried?
Sir, please, you are still on it.
Amiaraba, have you tried?
Please, I'm still on it.
Okay, hurry up. Hey, Akuya, what did you get?
Studio, please, I had 1.26 seconds.
We shall see.
Sir,
Yes.
please, since you didn't give us the question, I don't really have enough information on.
Well, yeah, some more visa. The information you need is right on the board. It said calculate the time it will take to cover the first 5 meters. And you are saying you don't have enough information. Eh? Hmm? Do I send a question to you?
Yes, sir.
So I've sent a question to you. Okay, let's solve it.
Yes, I've seen it.
I'm coming. So let's look at it. Now, you see, this is a body which was initially at rest and was acted on by this number of forces. Okay, because listen to a body of mass resting on a smooth surface. A body of mass resting on a smooth surface is acted upon by the forces, blah, 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 blah. Okay, so the body was initially resting, meaning its initial velocity, u is 0. Then when this number of forces acted on the body accelerates. Its acceleration is this. So if we are to calculate the distance, the time taken to cover the first 5 meters, then using S is equal to UT plus half AT squared. U is 0, so this part of it goes to 0. The distance, we are looking at the first 5 meters. This is equal to half A, which is 3.153 times T squared. T is what we are looking for. So we have 10 divided by 3.153 equals to T squared. Therefore, T is equal to, yes, 10 divided by that. 10 divided by 3.153. And so we have this. When you take the square root of the answer, you have 1.78. You have 1.78 seconds. Okay, is that what did you get?
1.26.
26. How did you do it?
I used the momentum formula.
That
F is equal to rate of change of momentum over time.
so let's see.
Then I made
Ft is equal to mv minus mu. Is that what you use?
No, I
And that's what she's doing with it.
So now, but the point is that you see what you are using is correct, oh, because F is the resultant force. Then, because the initial velocity is zero, the initial momentum is zero. But you must know the final velocity. Okay, when the body is acted or accelerates to this.
found the final velocity using s over t, distance over time.
No,
Then I
no,
substituted that into the
no,
time form.
Epia. This is a motion we started from rest. Okay, and then the body accelerates. So to get the final velocity, you must use v squared is equal to 2as. U is 0. You must use this. U is 0. So v would be square root of 2 by the acceleration, which is 3.153. Then the distance in question is 5. Okay, so let's use that to find v. So 2 by 3.153 times 5. That's it. So that when you take the square root of the answer, you have 5.62. 5.62 meter per second. Okay, so that the time would be equal to the mass. What's the mass? The mass is 10, I guess. Yes.
Yes, please.
Times 5.62 divided by the resultant force, which is 29.813. Let's see. Multiply, divide, let's see. So this one gives you a time of 1.88.
6, 7.
Pardon?
Yes, please.
Please, are you following what I'm saying? So 56 divided by 29.813. And this is 1.89, approximately 1.89. It's because we have, the more you approximate, the more the value also drops. Okay, so if you are going by this, you are right, but you must determine V from it. Please, are we okay? Gerard and Kwa, are you okay? Mami Araba. Janice, are you
Yes,
fine?
yes, please.
Okay. All right. So that's it. Then that question, no. Okay. The next thing I want us to look at is on movement, because you see, we have done omega, we've done movement. Over here, we haven't done movement. Okay. So I want to treat movement today and then our next meeting, so that when we return from break, okay, then we can treat other topics such as light and all. Okay, because at dynamics we must be at par. Dynamics laws of motion, moments, momentum, collision, and all that. We must be at the same length. So we are going to discuss moment, which we have treated in omega. So Equia Ishira, if you are okay, if you think you're okay in moments, you can go off. Is that okay? If you think you are so okay and the moment, Equia and Ishira, you have done it in omega classes. You can go off so that the rest of us will do it. Is that okay? All right. So, moment of a force. The moment of a force. When we talk about the moment of a force, technically we say that the moment of a force is a turning effect produced by a force. So this is defined as moment is defined as the turning effect produced by a force. Practically, how do we apply or see movement in our homes? You see, when you are entering into your room, your door connects to a door frame. So your door, which is this, connects to a door frame by a hinge. So there is a hinge, there is a door frame. There's a hinge, there's a door frame. Now, whenever you want to open, you exert a force on the handle, on the door handle. So you either hold it, turn, and then pull or push. When you pull or push the door, it creates a turning. The door turns around this. This is the hinge. The hinge serves as the pivot. So that turning effect created either in the clockwise or in the anti-clockwise direction is what we call as the moment. Another application of moment is that the carpenters remove nails from the wood using either hammer or crowbar. So the nail in position within the wood. Then a force is created or exerted on the pinch bar, and as a result, pulls the nail. This is application of moment. Force multiplied by a perpendicular distance from the point of rotation. Another clear application of moment in school, seesaw. You have a bar. Then this bar is placed on a point, pivot. Then somebody sits here, somebody sits at the other end. And then you see turning effect happening. So somebody exerts a force, and then as you exert the force downwards, if this one happens to be less weighty or sits at a longer distance from the pivot, it can be turned. So we create turning effect. So that is applications of moment around. I know you can mention a lot, but moment is defined by or as the turning effect produced by a force. How do we measure moments produced by a force? Moment produced by a force is calculated by, we are saying moment or torque is equal to force times the perpendicular distance. Perpendicular distance from the pivot or axis of rotation. Okay. Now, what it simply means is that if we have a beam and then the beam happens to be pivoted at a point, let's take the middle. So that this is the axis around which rotation takes place. Then a force is exerted on this. The magnitude of the force, let's call it F. The distance from the pivot, which is the axis of rotation, to where the force acts is X. For us to comfortably calculate the turning effect, this force exerted in this direction must make an angle of 90 with a perpendicular distance. And you can determine the force by multiplying, you can determine the moment, turning effect, by multiplying the force by the perpendicular distance. Meaning that moment is directly proportional to the force and also directly proportional to the perpendicular distance. So when any of these two increases, the turning effect would also increase. So if I have this arrangement, then this force F1, as I said earlier, is at a distance X from the pivot. Then a force F2 is also at a distance X prime from the pivot. Then I have another force F3. This is F3. F3 is at a distance of X2 from the pivot. It means that if you have to calculate the turning effect produced by all of them, moment one will be equal to the force F1 by perpendicular distance X2, non X1. Then the moment two would be equal to F2, okay, the labeling isn't in order. So this is F1, okay, F1X, F2X1. And then the moment 3 will be equal to F3 times X2. Which of these instances will produce a larger moment or a greater moment? Yes. Which of these instances would produce a greater moment?
Sir, please, F3.
So F3, yes, more views. Gerald, Kenneth is suggesting F3 will produce a greater moment. And please, here it's the assumption is that we are looking at all the forces having the same magnitude. So F1, the magnitude of F1 is equal to the magnitude of F2 and also equal to the magnitude of F3. So which of these three instances will produce a greater moment or turning effect? Yes.
Sir, please, F1. One.
Gerard has come again. F1, yes. Equia and Co. What do you also think?
Sir, please, that was Kenneth, not Gerald. And my view is F1.
F1.
Yes, sir.
F1. What about Mami Araba? Mami Araba, what about you? Mami Araba, are you
Please,
there?
yes, please. No
Which one?
idea.
Mami Araba, are you following?
Yes,
Eh?
please. Yes,
I
please.
I said moment is equal to the product of the force and the perpendicular distance. Now, moment is directly proportional to the force. Moment is also directly proportional to the perpendicular distance. Meaning that if any of these two increases, moment would also increase. If any of these two increases, moment would also increase. Are you okay? Now, we have several forces. F1, let me draw it again. Yanis, are you there?
Yes, please.
Are you following the discussion?
Yes, please.
Okay. So, because of Mami Araba and Co, I'm going over for the last time. So we have this bar. Now we have three forces acting on the bar. F1. The perpendicular distance of F1 from the pivot, this is from the pivot to where F1 is, we have X1. Then we have another force, F2. The perpendicular distance of the force F2 from the pivot, this is X2. Then a last force, F3. The perpendicular distance from the pivot to where F3 is X3. Now, Mami Araba, what I'm saying is that the magnitude of F1 is equal to the magnitude of F2, which is also equal to the magnitude of F3, meaning all the three forces have the same magnitude. All the three forces have the same magnitude. Now, which of these forces will produce a larger moment or turning effect? Don't forget, I told you moment is directly proportional to the force and also directly proportional to the perpendicular distance. So, since the forces have the same magnitude, F1, F2, F3 do not vary from each other. But Mami Adwa, what varies here? What varies from the diagram drawn on the board? What varies?
Please, the distance.
The perpendicular distance is what varies. So the moment produced by force 1 will be calculated by the perpendicular the force, which is F1, times the perpendicular distance, which is what is the perpendicular distance of x1? What is the perpendicular distance?
Please of
The perpendicular distance of F1 from the pivot. Janice, what is it? The perpendicular distance of F1 from the pivot. Janice, Mami Araba, what is the perpendicular distance of F1 from the pivot?
please x1.
X1. Then the moment 2. F2 times what's the perpendicular distance? What's the perpendicular
X2.
distance from Mami Araba? Hurry up with your response. Janice, contribute. Then moment 3. F3 times
x3.
Now the question is that which of these 3 moments would produce the greater or the largest turning effect? Which of these?
Please x1. The moment 1, sorry.
Why? Why do you think it will be the force F1 will produce the largest turning effect? Why do you think so?
Please, because the x1 has the largest distance.
Exactly. Okay, so moment depends on the force, magnitude of the force and the perpendicular distance. So here, if once all the forces are the same and then the distances vary, the one with the larger perpendicular distance would obviously produce the largest turning effect or moment. Please, is that okay? Okay, have you gone to sleep?
No, please.
Okay. Florence, who is Florence? Hello, Florence.
Yes, please.
Is it your first time of joining?
Yes, please.
Oh, okay. Welcome.
Thank you.
Florence from Florida. Okay. So moment does that. Okay. Now moment is a vector quantity. And Florence, what is a vector quantity? What is a vector quantity? Florence, when we say a vector quantity, what is it? Okay, Akuya, what is a vector quantity?
It's a quantity that has direction, both magnitude and direction, specified direction.
Okay, so it means that moment, okay, has both magnitude and then direction. Okay, so the turning effect of a force is a vector quantity, meaning it has both magnitude and direction. Now, Mami Araba, what do you think will be the SI unit of moment? What do you think will be the SI unit of moment? Or let me give it to Janice. Janice, what is the SI unit of moment? Janice, what is the SI unit of moment? Hey, Janice, are you there?
Yes, please. Newton meter.
Let's save time with our responses, please. The SI unit of moment is Newton meter. Okay, so this is how to calculate it. Now, there can be a situation where the force cannot be directly perpendicular. Example, you have this. We have the same a bar. This is pivoted at a point. So this is the point where rotation takes place. This is the length of the pivot. Oh, sorry, the bar, L. Now, this force F acts at the end. The force makes an angle of theta with the length. So it's like holding the bar and then pushing it at an angle. And you are asked to find the perpendicular, the turning effect produced by this force acting on the bar at such an angle. What is the turning effect produced by this force? When one of it isn't directly perpendicular, ideally this is what we expect. If we have something like this, the length and then the force acting on this perpendicularly, hooray, you are free to go. There's the length from the pivot, L. Okay. If you have something like this and you are to calculate the moment or the turning effect is simply F times L. F times L because the force is perpendicular to the length. So, okay, baby. But over here, it's not directly perpendicular. The force isn't directly perpendicular. What do you do? When you have a situation of this nature, two things. What you have to do is that, one, you are looking for, or you can extend this line so that if this angle is theta, what will be this angle? Mami Araba, if this angle is theta, then what will be this acute angle? Mami Araba, you have this. If this is theta, what will be the remaining angle?